Okay, so let's take a look at the solution of the exercise. Okay, as you can see, the battery's positive is connected to the left end of my switch, and for the second switch the positive is connected to the left end again, right? And the resistance is connected to the second end, and the same end is connected with the second end of my switch 1 either, switch 1 also, right? That's what I did. Positive to my switch S1, positive to my switch S2, and the common resistance, right? So that's how my circuit is going to be. And then again, the second end of my resistor is connected to the positive leg of my LED, and the negative is connected to the ground. Okay, so second end of my resistance connected with the positive leg, and the negative leg of LED is connected with the negative of my battery. So that's how the circuit is made, and let's take a look at the table. What will happen if both my switches are open, 1 and 2, 1 and 2 are open? Apparently there won't be any current flowing in the circuit because there's no closed path for current to flow, right? The current needs a closed path. So my LED would not glow. It would remain in off status, or I can also denote it 0, right? When my switch 1 is open and 2 is closed, 1 open, 2 closed, current will start flowing through switch 2, passing through resistance R, and eventually glow the glow the LED, I'm sorry, right? So LED status would be on. Likewise, when my switch 1 is closed, 2 is open, current will start flowing through switch 1, passing through resistance R, and eventually will glow my LED. So LED status would be on. Now both switches are closed, current will start flow and can flow through either switches. Now depending on the internal resistance of the switch, which is very low, just assume that. So there won't be any difference in the value of current up to this point here. Okay, now the current will drop somewhat here at resistance because that's what the purpose of resistor, and the LED will glow, right? Because current is still flowing, there is closed path. So if you say the open position is 0 and closed position is 1, off as 0, on as 1, what is happening is when both the inputs are 0, the output is 0. When either of the input is 1, output is 1, right? Which is essentially the OR gate, the typical characteristic of OR gate. Now this circuit is a parallel circuit, right? Because the current has two paths. Current can flow either through switch S1 or S2. So that's why it's a parallel circuit. We have discussed it, right? Now this is the OR gate symbol, as you can see here. If you take a look at the truth table, so what would be the output if the input is 0? Both the input are 0, output would be 0. If either of the input is 1, your output is going to be 1. Even both your inputs are 1, the output is still going to be 1, it's not going to be 2. So that's how the logic gate works. Now let's take a look at the second exercise. So this is the breadboard view of the second example, right? So the positive is to the left end of my switch, right? The positive supply to the left end of my switch S1, and then the second end of my switch S1 is connected with the, as you can see, this shortening is to the first end of my switch S2, right? Like this. And the second end of my switch S2 is connected with the first end of my resistor, second end with the first end of resistor, and the second end of resistor is connected with the positive of my LED, and the negative of my LED is connected through the ground, right? Like this. So this is a series circuit, right? Series circuit. Now let's take a look at the table. So what will happen if both my switches are open? That's pretty clear. There is no closed path, so no current would be able to flow through the circuit. So LED would remain off, right? Off. If switch S1 is open, S2 is closed, then also current cannot flow because this circuit is breaking at S1, so there is no closed path, no current, so no glowing LED, right? Off. Switch S1 is closed, but S2 is open. Again, there is open circuit, it's not closed, so current cannot flow through it, so LED would remain off. Now, if both the switches are closed, then it's a closed path, right? And the current will start flowing through this circuit, and LED would eventually glow, right? So if open is 0 and close is 1, off is 0 and on is 1, then when both the inputs are 0, my output is 0. If either of my input is 0, my output is 0. My output is 1 if both my inputs are 1, right? Which is a typical characteristic of AND gate, right? Where you are multiplying A into B. And this is the symbol of AND gate. And your series circuit could be said an AND gate also, right? Because it's exhibiting the same characteristic, right? So here is the truth table for AND gate. When both my inputs are 0, my output is 0. When either of my input is 0, my output is also going to be 0 because it's A into B, right? Now, when both the inputs are 1, my output is 1. So that's how the series circuit or AND gate works. Now let's take a look at the third example. Okay. So the positive of the battery is connected to the left of my switch, right? Like this. The left of my switch is also connected to the first end of my resistance, right? So this is also connected with the first end of my resistance. Okay. Like this, right? Now the second end of my switch is connected to the ground. Second end of my switch is connected to the ground, right? And the second end of my resistance is connected to the positive leg of my LED, right? Positive leg of my LED. And that's how the circuit is made, right? Now the switch S1 is open, so current will flow through resistance R and my LED would remain glowing or would remain on, right? Let's take a look at the table. When my switch is open, the current will flow through resistance R and LED would remain on. When I close the switch S1, it's a short circuit, right? And LED would remain open or on, or off, I'm sorry. So if open is 0, on is 1, then when my input is 0, my output is 1, and input is 1, output is 0, right? Which is a typical characteristic of NOT gate. NOT gate. This is the symbol of NOT gate, a triangle and a dot. Let's take a look at the truth table. When the input is 0, output is 1, input is 1, output is 0. So that's how the NOT gate works.